Hi all. So today we learn how to set and clear a bits of a given position. So basically, how we can set the kth position of a given number, and similarly, how we can clear also. Suppose if somebody is given a number, clear the kth position. So suppose somebody is given a number, so how you can set the kth position or clear the same kth position. So mostly we'll focus on these two parts today. So let's start with that. Maybe we can write fmt.println and we can give something like that. Uh, the number after set kth position. Each, or we can call a function. So let's take one example. Func set kth bit, and this function will take two input. One is n. This is the n is nothing but the number, and the position, maybe the kth position, and those both value will be integer. And then this function will return the integer, which is nothing but after setting the kth position, the overall the value of the n. So maybe we can say that return n. And then we'll write the logic here. Logic of setting kth position. So that we will discuss now. Okay, so take one example. Let's say we are calling a function from here. And let's say this is taking two input. One is, let's say, 21 we have given, and you want to set a third bit. So take one example of 21 and third. So in this example, maybe we can say that, let's say n is given 21, okay, and k is given 3. Meaning is that if you convert this 21 to a binary, so it will be nothing but 1 0 1 0 1, and it is asking that set the third position. So if you count it, this is 0 1 2 3. So they want that you set this 0 to 1. So how we can do that? So the logic is simple. What you can do, you take one number and perform k time left shift. What I mean is, let's say there is a number 1, and if you perform one time left shift, I mean one left shift, uh, one left shift 1. So what will happen? This is 1, and it will go to the left side. So this will be 1, left side 1 0 will be put, and again the remaining 0 will be there. This is one time. Second time again, if you perform the second time 1 left shift of second 2, so this is nothing but 1, and then 2 0 will be at right side and remaining 0 will be left side. Similarly, 1 left side, left shift 3, then third will come here, 3 0 will be right side and remaining 0 will be this side. So what you have to do, you have to give a number 1 0 1 0 1, then perform how many position they want to set it. Let's say the third position. So perform the 3 times left shift. So in this example, 3 after the 3 time left shift, the value will be 1, 3 times 0, and then left the remaining 0, and perform the OR operation. So this is very much important. We have to perform OR operation. What is the main logic is, you can see here, now this is just 1, and remaining left and right bits are 0. So if you perform OR with the 0, the same value will be there. Now just perform the OR operation on these two bit set. So this will be 1 0 1, this will be 0, this will be 1. This will be now set as a 1, because 1 0 is nothing but 1, and this is the 1. So this is overall the value after set position, which is nothing but, so this is 16, 5, 21, and then 5, 0, 1, 2, 3, 16, 8, 24, and then 5. So 29 value should be there as a output. So let's code it now. So the same logic will apply. What we'll do, we'll simply, either you can store it to here, simply we can return, or maybe we can say that x is equal to 1 left shift a that we have done, and then perform the OR operation with n, and this return x. So this value will be now left shift 3 times and the n with in this case 21, and then resultant will store in x, and then we can return. So let's run this program and see what's the output we are getting. Go run set. So as I mentioned that the value should be 29. So you can see here the number after kth position set is 29. So this is all about the set bit. Now let's understand the clear bit. So again, we can write a function that which will take uh, 2 parameter clear kth bit, and here again n and k, and let's say both will be integer, and again it returns the integer, and here again we can say that return n will, and here we can have a logic of clear. So let's understand the logic of the clear. So if you see the set bit example, so in that we are doing the OR operation. So the same examples we can take with the 21. So let's say n is equal to 21. So if you convert this to a binary, which is nothing but 1 0 1 0 1. Let's say you want to make it clear of this 1, which is nothing but 0 1 2. So in this case, let's take example of k is equal to 2, which will be resetting or clearing this bit, second bit. So in this case, the same similar logic we can apply. What we can do, take 1 and shift 2 times. Whatever the k position is given, left shift perform 2 times. So if you perform 2 times left shift, so what will happen? If you perform 1 time, it will be 0, remaining will be 0. If you perform 2 times, so 2 bit will be right side, remaining will be 0. So now we are done with 1 left bit, left operator shift 2 times. This will be the resultant. Now in this case, since we want to clear this bit, clear this means unset it. I mean just make it 0. So what we can do, we must need to have 0 here so that we can apply some operations. So the one example, the one solution is just make this as an inversion or not operation. So if you make it inversion, so what will happen in the Go language? This is the operators we can use it. This will do just invert all these bits. So whatever the 1 is there, it will be 0, and whatever 0 will be there, it will be 1. So this is the now inversion part is done. So the original number was 1 0 1 0 1, and after inversion we got this the value. Here what we can do, we can perform the AND bitwise AND operation. Bitwise AND operation. So what will happen? What remaining 1 will be if you perform the AND operation on with 1. So the same value will be there, whatever the n bit is there originally. So let's start with that. 1 is 2, 1 and 1 is 1. 1 and 0 will be 0. 0 and 1 will be 0. Now you can see here we have just cleared it because only second bit is the 0 in our case. 1 0 will be 0, 1 0 will be 1 and 1 will be 1, which is nothing but 0 1 2 3 4 16 and 1 17. So 17 as in integer number should be there if you are going to set second position of the integer 21. I hope it's clear. The main logic was perform the second bit here, second two times, uh, and then just invert it, overall number. So 0 will convert to 1, 1 will be 0, and then perform the AND operation. So just code it now. Let's see. So again here, let's say we can do Y and we can perform with N and AND operation, and then inversion of 1 2 times left shift. So basically K times left shift, okay, and return Y here. So this will be the resultant value. Just for example, we can print it the same message. The number after clear kth position is here. This we can use this function, and we can give position number as 2, comma 2. Okay, let's run this. So you can see here the after setting 21 we are getting resultant, and after clearing second position 17 we are getting resultant. So that's it for the today. Thank you.